In this question, you can assume that the temperature remains constant throughout, and since this is an enclosed system, so you'll be applying PV equals to a constant. So naturally, you'll be using P1V1 equals to P2V2 for these two scenarios. But this question is a bit different because in scenario 1, the two cylinders, they have different condition as you can see here. So I have to make something constant, and for this case, let's going to make the pressure to be P for both cylinder. Since cylinder A is already at pressure P, I'll be working on cylinder B. Now if you consider cylinder B to be like a piston that you're familiar with, okay, right now the volume is 100 cm cube and the pressure right now is equals to 2P. But if I have to pull the piston out slowly so that there's no change in temperature, okay, let it be B prime, the pressure now, and I want it to be P, therefore what is the new pressure? What's the new volume? So by right you should know that it's about 200 cm cube. But if you are not sure, you can apply P1V1 over here equals to P2V2, where the pressure here is 2P, the volume is 100, and the pressure in this scenario now is P times the volume, which is what you want to find. So the volume into here will be 200 cm cube. So it's like you can actually consider cylinder B to be this scenario also, because the number of air molecules, everything is still the same. So having done that, you can consider scenario 1 and 2 now. So I'll be applying P1V1 equals to P2V2 here. So the pressure now is fixed at a constant P times the total volume will be the volume of the cylinder B, which is 200 plus the volume of the cylinder A. So total will be 400. And after the tap is open, the pressure 2 is what you want to find in terms of P, and the volume will be the original 100 and the 200 in cylinder A. So the total volume will be 300. So if you can solve your P2, it will be 4/3 times P. That's how you get the answer. Of course, if you want to fix the pressure to be 2P, it's fine also. Okay, that's method 2 in the block. So you're going to consider cylinder A to be 2P and the volume will be 100 cm cube, and then you can use the same techniques to solve. So that's how you solve this question.